Okay, so let me start section 0.3, rational exponents and radicals. So the cube root of 8 is 2 because 2 cubed is 8. So the cube root of 8 is 2 because 2 cubed is 8. 8 is called the radicand. This symbol is called the radical symbol, and this is called the index. If our index is 2, we don't write the index. The principal root is defined as follows. If a is non-negative and n is an even natural number, then b is equal to the nth root of a is the real number, b greater than or equal to 0, such that b to the n is a. If n is an odd natural number, greater than 1, then b equaling the nth root of a is the real number such that b to the n is equal to a. So note that the even root of a negative number is not yet defined. Rational exponents. So we've already defined in the previous sections a natural number exponent, a whole number exponent, and then an integer exponent. Now let's try to define the rational exponents. So if n here is a natural number greater than 1, then a to the 1 over n is defined as the nth root of a, under the assumption here that the nth root of a is defined. So again, as always, I'm assuming here when I write this statement that if one side, either both sides are defined or both sides are undefined. If m and n are natural numbers, then a to the power m over n is defined as the nth root of a to the m, or similarly is defined as the nth root of a to the power m, so long as n here is not equal to 1. As before, a to the power negative m over n is equal to 1 over a to the m over n. The nth root of a to the n will be the absolute value of a, so long as n is an even integer, and is equal to a if n is a odd integer greater than 1. Let's do some examples. On page 39. Oh, this is going to be really short. Let's simplify each expression. The cube root of 8 over 27. Well, the cube root of 8 is 2. The cube root of 27 is 3. So my answer is a negative 2/3. Simplify each expression. Use absolute value symbols whenever necessary. So this is equal to the square root of 25a to the 4. Well, the square root of 25 is 5. The square root of a to the 4th is a squared. And I do not need any sort of absolute value because a squared is never going to be negative. Let me do problem number 63. Simplify each expression. Assume that all variables represent positive numbers, write all answers without negative symbols. So negative exponents. So this is equal to, yes, question. No, oh, which one? Uh, 16. Yes, yes. So I have an exponent of 1/3. And so an exponent of 1/3 is just the same as a cube root. Well, what's a cube root of 8? 2. Because 2 times 2 times 2 is 8. What's the cube root of 27? 3, because 3 times 3, 9 times 3 is 27. Any questions about that? You got it? Okay, okay. You're welcome. Okay, so let me do a to the 2/5 times a to the 4/5 divided by a to the 1/5. So I have here the same base. Since I'm multiplying, I'll just add exponents. Well, 2/5 plus 4/5 is 6/5. And now I am dividing, so I keep the same base and I subtract exponents. Well, luckily, I have a common denominator. So 6/5 minus 1/5 is 5/5. But 5 divided by 5 is just 1. So this is a to the 1, which is just a. And so my answer is just a. Okay. Let me do problem number 72. Simplify each radical expression. And so let's do that. Well, I want to simplify the 4th root of 256 over 625. Well, the 4th root of 256 is 4. Since 4 times 4, 16, times 4, 64, times 4, 256. And so the 4th root of 256 is 4 over the 4th root of 625. 5 times 5, 25, times 5, 125, times 5, 625. So the 4th root of 625 is 5. Therefore, the 4th root of 256 over 625 is 4/5. Let me do problem number 71. The 5th root of negative 32 over 100,000. Well, the 5th root of negative 32 is going to be negative 2. Negative 2 times negative 2, positive 4, times negative 2, negative 8, times negative 2, positive 16, times negative 2, negative 32. So the 5th root of negative 32 is just negative 2. Next. The 5th root of 100,000 is 10. 10 times 10, 100, times 10, 1,000, times 10, 10,000, times 10, 100,000. Well, you can actually simplify this. And so I can divide both 2 and 10 by 2. So this is just a negative 1/5. And that is your answer. Let me do problem number 81. Simplify each expression. Assume that all variables represent positive numbers so that no absolute value symbols are needed. Well, if you notice here, I have a square root of 8 minus the square root of 2. Neither of these are like terms, so I can't combine them unless I simplify this. I can write 8 as 4 times 2, and the square root of 4 is 2. And so I can simplify rad 8 as 2 rad 2. So now I have 2 rad 2 minus 1 rad 2 is just 1 rad 2. And that is your answer. Let me do problem 94. Radical 512 x to the 5 minus radical 32 x to the 5 plus radical 1250 x to the 5th. Well, let me write this as 512 is 256. 256 x to the 4th times 2x. So I'm writing what's inside the radicand as the product of two terms, one of which is the largest fourth power. And so 256 x to the 4th times 2x minus. So do the same thing. Let's write 32 x to the 5th as 16 x to the 4th times 2x. And lastly, let's write 1250 x to the 5th as 625 x to the 4th times 2x. And so the fourth root of 256 is 4. I think we did that above. 4, 16, 64, 256. The fourth root of x to the 4th is x. Again, they're telling us we don't need absolute values. Normally we would need absolute values, but they're saying that x is greater than 0. And so what remains is rad 2x. The fourth root of 16 is 2. 2, 4, 8, 16. Fourth root of x to the 4th is x. Lastly, the fourth root of x to the fourth root of 625 is 5. 5, 25, 125, 625. The fourth root of x to the 4th is x. And what remains is rad 2x. And so I have the following. So this is equal to, well, notice I have an x rad 2x for each of these terms. So these are all like terms. So I have 4 of these minus 2 of these plus 5 of them is 7 of these x rad 2x. And that is your answer. Let me do problem number 96. Rationalize each denominator and simplify. Assume that all variables represent positive numbers. Okay. So let's do that. So to rationalize the denominator, let me multiply and divide by rad 5. And so this is equal to 6 rad 5 times rad 5 times rad 5 is 5. And that is your answer. So I've rationalized the denominator. Next, let me do problem number 99. So again, I want to rationalize the denominator. But in this case, I have a cube root. And so I want to get rid of the cube root. Well, so I want to multiply by something to get a perfect cube. Here we multiply by rad 5 so that the denominator would have a perfect square. Now we want to multiply so I get a perfect cube. Well, 2 times 4 is 8. The cube root of 8, well, 8 is a perfect cube. So I can actually simplify that. So this is equal to 2 rad 4 over the cube root of 8, which is 2. And so the 2's cancel, and I just get the cube root of 4. And that is your answer. Oh, I must have missed the what the question was. But this obviously, so somehow I missed what the question is asking. But this is obviously has to be asking to rationalize the numerator. So somehow this is missing a question here. I want to rationalize the numerator, and so I'll multiply and divide by rad 5. Okay. And so I get rad 5 times rad 5 is 5 for 10 rad 5. But I can simplify this. This is equal to, well, 10 divided by 5 is 2. And so this is equal to 1 over 2 rad 5. And that is your answer. Okay. So here, again, I'm missing the question, but it has to be to simplify this as much as possible. So let me rewrite this as let me rewrite these radicals as a base with a rational exponent. So square root is a exponent of 1/2. A cube root is an exponent of 1/3. Now I have the same base, and I'm multiplying, so I need to add exponents. Well, to add fractions, I really should have a common denominator. So 3/6 and 2/6. So I can rewrite 1/2 as 3/6. I can rewrite 1/3 as 2/6. So now I can multiply. I'll keep the same base and add exponents. 3/6 plus 2/6 is 5/6. And so lastly, oops, I don't need the hat. This is just the 6th root of 2 to the 5th. Well, 2 to the 5th is 2, 4, 8, 16, 32. And so the square root of 2 times the cube root of 2 is the 6th root of 32. And I guess that's it for today. Ooh, is that really? Yeah, this was a short section. Okay, so that's it for today. Let me